Today's notes are on Introduction to the Laws of Exponents. The objective is to simplify an expression containing integer exponents. Remember that the notation a to the n means that we're going to multiply a n times. We can write that out as repeated multiplication, so it would look like a times a times a times a, and we would do that n times. And that's how we expand an exponential expression into its factored form. Okay. Now, in the event that we have one or more like-based exponential expressions being multiplied together, like x cubed times x to the fifth, okay, we can expand that out into multiplication. So x cubed, which is x times x, and x to the fifth, which is x times x times x times x times x, we can expand out, okay? Now, we really don't need to have those parentheses there. We can technically remove them and write it all as a single string. And if we do that, we actually see that we have 8 x's being multiplied, so we could write that as a single simplified exponential expression of x to the 8th. Okay, here's our next one, y to the 7th times y to the 4th. So if we expand it out, we've got 7y's being multiplied and then 4y's being multiplied. We can then remove the parentheses. And we are left with y to the 11th. We have 11 y's being multiplied together. Okay. Now, that can be very cumbersome to do every time. We were able to just do it just then because our exponents were relatively low. But if you had something crazy like z to the 5th or z to the 44th, I don't expect you to sit there and write out 50 z's and 44 z's, okay? That's when we're going to use a shortcut, okay? Some of you may have noticed in the previous slides that 7 plus 4 was 11, or that 3 plus 5 was 8, okay? We're going to be able to use a shortcut where we add the exponents together, okay? So, anytime we're multiplying like bases, we can add the exponents. Therefore, z to the 50th times z to the 44th would actually end up being z to the 94th, and we get that by just adding 50 plus 44. Okay. Now, in the event that we have coefficients or different bases, different variables in the bottom, okay, we're going to use our knowledge of the associative and commutative properties to rearrange the terms. Okay, so if we have something like negative 3x y to the squared times 5x to the 4th y to the 5th, we can rewrite this as negative 3 times 5, x times x to the 4th, and y squared times y to the 5th. Now notice that with that x, I went ahead and wrote in an exponent of 1 with it. Anytime you have a variable that doesn't have an exponent written with it, technically it has an exponent of 1. So you can always write in that 1 if it helps you remember that it's there. Okay. Now, at the point at which you rearrange the terms using the associative and commutative properties, okay, you can just go ahead and use the rules that we already know. Negative 3 times 5 is negative 15. And then we add our exponents for the x base, which would give us x to the 5th, and we go ahead and we add our exponents for the y base, which would give us y to the 7th. And voila, we have our answer. Okay, here's another one. 7 times a squared b cubed c. times 5ab to the fourth. Okay. We'll regroup our terms. 7 times 5, a squared times a, b cubed times b to the fourth, and then c. Notice that c it's by itself, so it's going to stay by itself, and we're not going to join it with anything because there's no other c's to group it with. Oops. And if we were to simplify this, we would end up with 35 a cubed. Remember that that a technically has an exponent of 1, and 2 plus 1 would give me a 3. B to the 7th. 3 plus 4 gives me 7, and my c just stays a c. Okay. Now let's take a look at division. Okay. X to the 5th over x squared. Okay. We can write this out just like we did the multiplication. Okay. Expand, and we end up with x times x times x times x times x on the top, and x times x on the bottom. Okay. Now, remember that any number over itself simplifies to 1. So, if you look at the first set of x's, okay, x over x right here is going to simplify to 1. And then the next set of x's, x over x, would simplify to 1. Okay, now oftentimes we use the phrase that it cancels out, okay, but really technically they're going to 1. Okay. Now that just leaves us with the 3 x's on top there, okay, these 3 right here. And we'd be left with x cubed. Okay, our next example is r to the 27th over r to the 14th. Now, very similar to the multiplication ones, I don't actually expect you to write out 27 r's and 14 r's, okay? There's got to be a little shortcut here, okay? If you think about it, what do you think is going to happen? You're going to end up subtracting this time. You're going to do m minus n. So you're going to do the exponent on the top minus the exponent on the bottom. Okay. So if we did 27 minus 14, we would end up with r to the 13th. Okay. Now, it's very similar, again, just like with multiplication when we have coefficients and different bases in the bottom. Okay. Use the knowledge that you already know about division of integers. Okay. 25 over negative 5 is negative 5. You're going to treat that just like it were a fraction. And it would give you negative 5. Okay? R cubed over r is going to give you r squared. Now remember that r has an exponent of 1 technically, and 3 minus 1 would give you 2, r squared. And then we have s to the 7th over s cubed, and 7 minus 3 is 4. So we end up with negative 5 r squared s to the 4th. Now, here's the next scenario you're going to run into when you have a power to a power, okay? So this situation is a cubed to the 5th. So that means we're going to have a cubed times a cubed times a cubed times a cubed times a cubed. Now, if we were to continue to expand this, we would have a times a for each a cubed. Now, we learned before that we could then remove the parentheses and write this as a single string of a's being multiplied. Okay? If we were to do that, we would actually end up with 15 a's. Okay? So, hopefully, you'll start to pick up a pattern on what might happen there. Because again, just like the other situations, I don't expect you to be able to write it out every time. Because to write out q to the 6th to the 12th power would be very laborious. Okay, there is a shortcut to this. X to the m to the nth power actually is x to the m times n. So you're going to multiply the two exponents. Okay. So in this case, we would do 6 times 12, which would give us q to the 72nd power. Okay. Now, what do you think might happen here in this case where that exponent of 4 is outside that entire product? Okay. That 4 actually belongs to everything inside the parentheses. Okay. And you can see that rule illustrated here. Okay. Anytime you have an exponent outside of parentheses, that exponent belongs to everything inside the parentheses. Okay. So the 4 in this case is going to belong to the 2, it's going to belong to the a cubed, it's going to belong to the b to the 7th, and it's going to belong to the c. Okay. So using the rules that we've already talked about, 2 to the 4th means 2 times 2 times 2 times 2, which would give us 16. A cubed to the 4th, we're going to multiply those two exponents, 3 times 4, which would give us 12. B to the 7th time to the 4th would give us 7 times 4, which is 28. And then c to the 4th just stays c to the 24th, or c to the 4th just stays c to the 4th. All right, let's see what happens here. Remember that that 3 belongs to everything inside the parentheses. Okay, so we have negative 3 cubed, a cubed, cubed, and b squared cubed. Okay, so negative 3 cubed means negative 3 times negative 3 times negative 3, which is going to give me a negative 27. A cubed cubed, we're going to multiply those two exponents, is going to give me a to the 9th. And b squared cubed, I have to multiply those two exponents, is going to give me b to the 6th. And there's your answer. All right, I want you to try a few of these on your own. So go ahead and pause the video, try it, and see if you get what I get. How's z to the 23 sound? In this case, because we have like bases of z, we need to go ahead and add the two exponents. 9 plus 14 is going to give us 23, so we get z to the 23. Okay. Here, remember to use the commutative and associative properties to let you regroup the terms. Take a minute, pause this one, see what you come up with. So I grouped the 3 and negative 4 together and did 3 times negative 4, which was negative 12. And then I grouped the a to the 12th and the a to the 7th together. And then I added the two exponents, which gave me a to the 19th. So my final answer on this one was negative 12, a to the 19th. All right, here's a division one. Negative 35, c to the 6th over 7, c to the 4th. See what you come up with. Negative 35 over 7 is negative 5. And then c to the 6th over c to the 4th is c squared. And I got that by subtracting the two exponents. 6 minus 4 was 2, so that left me with c squared. My final answer on this one was negative 5c squared. All right, one more for you to try. Negative 2a cubed b c squared all to the 4th power. Think about who that exponent of 4 outside of the parentheses belongs to before you get going on this one. Pause it and see what you come up with. Remember that that exponent of 4 outside of the parentheses belongs to each piece inside the parentheses. So that's going to leave me with a negative 2 to the 4th, a cubed to the 4th, a b to the 4th, and a c squared to the 4th. Negative 2 to the 4th is like negative 2 times negative 2 times negative 2 times negative 2. That gives me a positive 16. A cubed to the 4th, I'm going to multiply those two exponents. 3 times 4 gives me 12. B to the 4th is just b to the 4th. And c squared to the 4th, I'm going to multiply those two exponents. And 4 times 2 is 8. That gives me 16, a to the 12th, b to the 4th, c to the 8th. All right, that wraps things up. So remember that we just went over several rules for simplifying exponential expressions. We have rules for multiplying, in which case we add the exponents when they have like bases. We have a rule for what happens when we divide like bases, where we subtract the exponents. The rule for when we raise a power to a power is that we multiply the exponents. And remember that it can be helpful to rearrange terms when we have coefficients or several bases or variables that we're dealing with. Okay? And also that sometimes it's helpful to add in a 1 when there's no exponent actually written in there, so that we don't forget about it. And remember too that if there's a exponent outside of parentheses, that that exponent belongs to everything inside the parentheses. Okay? If you have any questions on any of these examples or any of the rules, make sure that you write them down and bring them to class.